Hello grade 10 students! Let's get to know more about geometric sequence. This is Module 6. Target skills or objectives. Pre-test muna.
A few inches later.
We learned from our previous modules ang geometric sequence. Ngayon, let's recall it. Geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called common ratio or R. Meron tayong ginamit na geometric sequence formula which is a sub n equals a sub 1 times r raised to n minus 1. Ngayon, pag-uusapan natin ang iba pang pwedeng gamitan ng geometric sequence formula. Ito ang geometric means. Ano ba ang geometric means? Matatandaan na sa arithmetic sequence ay meron ding arithmetic means. Dito ang geometric means ay ang mga terms between any two non-successive terms in a geometric sequence. Ibig sabihin, ito yung term or mga term na makikita sa gitna ng dalawa pang terms ng geometric sequence. Let M be a geometric mean between two numbers A and B. Ibig sabihin, meron tayong mapo-form na geometric sequence na A, M, B. Matatandaan din na kinukuha natin ang common ratio ng geometric sequence by division. Dinidivide natin yung term by its preceding term. So kung gagamitin natin ang mga terms sa A and B to get the common ratio, ito yung makukuha natin. M over A is equal to B over M. Bakit equal? Because they are common ratio. By derivation, pwede natin itong maisulat as M squared equals AB na pwede natin gamitin to get our geometric means. O kaya, pwede natin i-extract yung root to get a simpler formula. M equals square root of AB. Since M squared is greater than 0, ibig sabihin bawal maging 0 ang M. Bakit? Kasi kung ano i-multiply mo sa 0, ang sagot ay laging 0. So, ibig sabihin the equation or yung formula ng geometric means implies that either both A and B are positive o kaya naman parehas negative. So muli, ito yung geometric means and geometric means formula na pwede natin gamitin in order to get them. Let's try example number 1. Find the geometric mean between 3 and 12. In this example, kailangan nating hanapin ang M or the geometric mean. Given ay yung A which is the first term 3 at yung B yung last term 12. Let's look at the solution. Let's use the geometric mean formula M squared equals AB. By substitution, A is 3, B is 12. Let's simplify. 3 times 12 is 36. By extracting the root, specifically square root, we'll get the square root of M squared equals square root of 36. And the square root of 36 is 6. Therefore, the complete geometric sequence is 3, 6, and 12. Let's try example number 2. Insert two geometric means between 3 and 192. This time, meron tayong kukumpletuhing sequence dahil dalawa ang hanapin na geometric means. So ito ang ating incomplete geometric sequence, 3, blank, blank, and 192. Let's look at the solution. Let's find R first or yung common ratio na pwede natin gamitin para kumpletuhin yung geometric sequence. Let's recall geometric sequence formula. A sub n equals a sub 1 times r raised to n minus 1. By substitution of our given, our n is 4. Bakit? Dahil meron tayong 4 na terms sa ating geometric sequence. Let's simplify the exponent. will become r raised to 3. Bakit naging 192 sa a sub 4? Dahil given siya sa ating example, yung pang-apat na term. Let's divide both sides by 3. Bakit? Para ma-isolate ang r raised to 3. So 192 divided 3 is 64. Now let's extract the root, the cube root of r cube. Para matanggal yung cube sa r at matira na lang is yung r. So ano yung cube root ng 64? It's 4. So our common ratio is 4. Now let's use the common ratio to complete our geometric sequence. By multiplying to the preceding term of the common ratio, we get the succeeding, which is 12. By multiplying again by 4, we'll get 48. To check, 48 times 4 is 192. Therefore, the two geometric means are 12 and 48. Let's consider example number 3. Determine the geometric sequence in which the third term is 1 over 8 and the sixth term is 1 over 64. Muli, meron tayong incomplete sequence pero this time ang binigay sa atin ay yung pangatlo at yung pang-anim na term. So nawawala si first, si second, si fourth, at si fifth. Let's look at the solution. Let's find first the common ratio. Now to find r, let's assume the third term to be a sub 1 and the sixth term as a sub 4. Bakit a sub 1? Because in the geometric sequence formula, kailangan natin ang a sub 1. Bakit a sub 4? Kasi mula sa 1 over 8, pang-apat si 1 over 64. That makes sense. Ngayon, let's have the substitution. So si a sub 4 ay 1 over 64, si a sub 1 ay 1/8, and yung n, dahil nga pang-apat na assume si 1 over 64, our n is 4. Now let's simplify the exponent. So 4 minus 1 is 3. Now multiply both sides by 8. Bakit? Para ma-isolate muli ang ating common ratio sa isang side. That gives us 1 over 64 times 8 is 1 over 8. 1/8 times 8 is 1. Kaya na-isolate na si r cube. Now, let's extract the root. Cube root of 1 over 8 equals cube root of r cube para muling matanggal ang cube sa r. Ano ba ang cube root ng 1 over 8? It's 1/2. So, our common ratio is 1/2. Let's use the common ratio to complete our sequence. By multiplying the common ratio to the term 1/8, we'll get the succeeding term 1 over 16. 1 over 16 times 1/2 is 1 over 32. To check, 1 over 32 times 1/2 is 1 over 64. Paano nga ulit mahanap ang mga terms sa unahan ng geometric sequence? So 1/8 divide 1/2 is 1/4. 1/4 divide 1/2 is 1/2. That completes our geometric sequence. 1/2, 1/4, 1/8, 1/16, 1 over 32, and 1 over 64. When we differentiate geometric sequence from arithmetic sequence, nagbigay ako ng example on how to find the nth term of a geometric sequence. Muli nating balikan kung paano gagamitin ang geometric sequence formula para mahanap ang mga nth term. Let's consider number 1 example. Find the 10th term of the geometric sequence 2, 4, 8, and so on and so forth. We will start again with our given. So alam natin na yung 2 yung first term at yung common ratio is 2. Galing sa 4 divide 2 and 8 divide 4. And syempre, yung hinahanap natin is yung 10th term or a sub 10. Para sa solution, we will be using once again our geometric sequence formula to substitute the given. Our n is 10 dahil ang hinahanap natin is yung pang 10th term. So 10 yung terms ng geometric sequence. Our first term is 2. Our common ratio is 2. By simplifying the exponent, 10 minus 1 is 9. Let's simplify 2 raised to 9. It gives us 2 times 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 2. We'll get 512. And syempre, we'll multiply 512 by 2, we'll get 1024. Therefore, the 10th term of the geometric sequence is 1024. Now, let's have number 2 example. Find R, or the common ratio, in a geometric sequence if the first term is 1/3 and the 8th term is 128 over 3. This time, common ratio ang hahanapin natin. So, paano gagamitin yung geometric sequence formula? Let's start with the given. Our first term is 1/3. Our 8th term is 128 over 3. Now, what is R? Let's solve. Given the geometric sequence formula, we will start with substitution. 8 is our n because yun yung last term na binigay sa atin. And syempre, yung a sub 8 is 128 over 3. Yung a sub 1 is 1/3. By simplifying the exponent, we have r raised to 7. And by multiplying both sides by 3 para ma-isolate yung r, we'll get 128 equals r raised to 7. Then by extracting the root, the 7th root, para matanggal yung raised to 7 ng r, yung 7th root natin yung 128. And that is equal to 2. That is our common ratio. Now, let's talk about example number 3. What term is 2,916 in the geometric sequence 4, 12, 36, and so on and so forth? So, ang hinahanap natin is kung pang ilang term sa 2,916. Pero bago yan, let's talk about the given first. A sub 1 is 4. A sub n is 2,916. Bakit? Dahil siya yung i-consider nating last term ng sequence. And yung r, which is the common ratio, is 3. Galing sa 12 divide 4 at 36 divide 12. So, ang hinahanap natin para sa number 3 ay yung n, or yung number of terms, or yung pang-ilan si 2,916. Let's solve. Again, let's use our geometric sequence formula. By substitution, our a sub n, considered as the last term, is 2,916. Our first term is 4, then our common ratio is 3. So, ang nawawala natin is yung nasa exponent na n minus 1. Sino ba si n? Let's divide both sides by 4. Bakit? Para ma-isolate si 3 raised to n minus 1 at maging maliit na number si 2,916. That gives us 729. Now, let's change 729 into exponential form with base 3. Ano bang ibig sabihin? Recall your exponential form. Gagawin nating base 3 ang 729 para maging pareha siya doon sa kabila ng equal sign na meron ding base na 3. At ang makukuha nating exponential form ng 729 ay 3 raised to 6. So makikita natin that they have the same base, which is 3. Yung exponent ng unang 3 ay 6, at yung exponent ng sa kabilang equal sign na 3 ay n minus 1. Let's perform the solution ng exponential equation with the same base. Ito yung susunod nating i-recall. Exponential equation with the same base. Based on the exponential equation, if x raised to a is equal to x raised to b, pareha sila ng base which is x, this implies or ibig sabihin, equal ang value ni a at ni b. So, sino-sino ang mga exponent na makikita natin sa ating solution? Si 6 at si n minus 1. They will become equal dahil galing sila sa magkaparehas na base which is 3. Now, let's continue the solution. Add both sides by 1. Bakit? Para ma-isolate si n at makuha natin ang value niya. That gives us 7. O kaya naman, pwede mong i-transpose ang negative 1 sa left side, magiging siyang positive 1. And 6 plus 1 is 7. That is our n. Therefore, 2,916 is the 7th term of the given geometric sequence. At para sa susunod na lesson, let's talk about sum of finite and infinite geometric sequence. Natatandaan ba yung pinagkaiba ng finite at infinite sequence? That's great dahil gagamitin muli natin ang finite at infinite sequence sa geometric sequence. Pero this time, we will talk about the sum of the geometric sequence. Yung sum of finite geometric sequence ay tinatawag ding finite geometric series, kung saan ang hinahanap ay yung total ng mga terms ng isang geometric sequence kapag inad. Ganun din yung sum of infinite geometric sequence. Infinite geometric series ang tawag sa kanya. So, hahanapin natin ang total ng mga infinite geometric sequence. So, paano? Let's look at the formulas. Una, sa sum of finite geometric sequence or finite geometric series, ito ang gagamitin natin. Kung saan, S sub n ay yung sum of the terms in the geometric sequence, A sub 1, muli ang first term, R ang common ratio, at yung n, yung number of terms. So, yung sum of finite geometric sequence formula ay S sub n equals A sub 1 times the quantity 1 minus R raised to n all over 1 minus R. At para sa sum of infinite geometric sequence, ito yung kailangan natin. This time, S ang sum of the terms. Bakit walang n? Very good. Dahil yung infinite geometric sequence ay walang katapusan. Hindi natin alam kung ilan yung number of terms. Pero meron siyang A sub 1 at meron siyang common ratio. Take note, ang common ratio ng sum of infinite geometric sequence ay dapat less than sa 1. Pwedeng fraction or pwedeng decimal. Tingnan natin ang mga examples. Let's start with the sum of finite geometric sequence. Let's find the sum of the geometric sequence 40, negative 20, 10, negative 5, 5 halves, and negative 5 over 4. So this is a finite geometric sequence dahil meron tayong eksaktong 6 na terms sa ating geometric sequence. Let's start with a given. Yung first term natin ay 40 at yung n natin ay 6 dahil 6 sila. Now, yung ating r ay galing sa negative 20 divide 40, 10 divide negative 20, and so on and so forth. They will have common ratio which is negative 1/2. Now, let's find S sub n. Kasi nga, we are talking about sum of finite geometric sequence. This time, we are looking for S sub 6. For our solution, let's use the finite geometric series formula. S sub n equals A sub 1 times 1 minus R raised to n all over 1 minus R. By substitution, our n is 6, our A sub 1 is 40, our R is negative 1/2. Alin yung uunahin natin? Let's simplify the following. Yung nasa loob ng parenthesis na 1 minus negative 1/2 raised to 6 ay equivalent sa 1 minus 1 over 64. At equivalent siya sa 63 over 64. Ngayon naman, yung nasa denominator na 1 minus negative 1/2 ay equivalent sa 3 halves. Please recall your operations and fractions. Let's continue. This gives us the result. 40 times 63 over 64 all over 3 halves. Now, by performing the operations and fractions, multiplication and division, we can see that S sub 6 is equal to 315 over 12, or in lowest term, 105 over 4, or in mixed number, 26 and 1/4. That is the sum of our given geometric sequence in our example. Ngayon naman, let's look at the example para sa sum of infinite geometric sequence. Find the sum of 3 over 10, 3 over 100, 3 over 1000, and so on and so forth. Again, this is an infinite geometric sequence. Given is A sub 1, which is 3 over 10. And our common ratio, which is from 3 over 100 divided by 3 over 10, 3 over 1000 divided by 3 over 100, we will get 1 over 10. Now let's find S. Let's solve. Using the infinite geometric series formula, S equals A sub 1 over 1 minus R. Ito yung ating substitution part. Yung A sub 1 ay 3 over 10 at yung R is 1 over 10. By simplifying the denominator first, we'll get 3 over 10 all over 9 over 10. And by simplifying or performing the operations on fractions, specifically through division, we will get S equals 1/3. So the sum of the given geometric sequence in our example is 1/3. Please try this. Given the geometric sequence 1, 1/2, 1/4, 1/8, and so on and so forth, find A, sum of the first 5 terms, and B, the infinite geometric series. Are we on the same page? Job well done. Now, answer more.
Practice exercises.
A few inches later.
Assessment time. Please answer post-test and additional activities.
Once again, thank you for watching, learning, and supporting. Always remember, be good, be mathly good. This is Remarkable Videos.